Okay, on page 23 at the top, you are going to summarize the 3 rules from last class and then try this problem. Pause the video here to have time to do that. So for a constant, okay, the derivative is, let's see if my pen will work, f prime of x will always be 0. And when we have a linear function, f prime of x, the derivative will always be the slope. And when we have a power function, the derivative is the n multiplies with the coefficient, and then we subtract 1 from the power. For what x values is the tangent line horizontal? So horizontal means slope is 0. And because we're in calculus, slope is the derivative. So we need to know where is the derivative 0. So first, let's find the derivative function. The 3 becomes the coefficient. Subtract 1 from the power. The 2 becomes the coefficient. Subtract 1 from the power. And then for 3x, you can think of this with a power rule. 1 multiplied by 3. Subtract 1 from the power. Or 3x is linear, like mx, so the derivative is just 3. And we see that here because x to the 0, that's 1. So this is really minus 3. These 3's divide, and that's minus 2x. We want to set the derivative equal to 0, and now we have to solve. We have a quadratic, so to solve that, we're going to factor. That's minus 3x plus 1. Set each factor equal to 0. And now what's nice is this question just says what x values, not what points. So the x values are 3 and negative 1. All right. So continuing on page 23, we now have the derivative of sums and differences. And we just used these rules on the warm-up. We have to officially state them because there is no such rule like these for multiplication and division. For products and quotients, we're going to get special rules in our next unit. We have the derivative of a f of x plus g of x is the derivative of f plus the derivative of g. Or subtraction, it works the same way. This dy dx notation is new for us, so I'm going to explain to you where it comes from. So the derivative, we know, is slope. So slope is y2 minus y1, x2 minus x1. Well, for slope, some mathematicians write the difference of y as delta y and the difference of x as delta x. So difference, delta, they both start with d. Well, since slope is derivative, we have a notation instead of delta y, we say dy, and delta x is dx. This is the same thing as saying f prime or g prime or y prime. So the derivative notation can either be a prime or it could be dy dx. All right, so pause the video here and try 1A and B. All right, so for A, we've got f prime of x is 2 times 5. Subtract 1 from the power. Minus, so that's this rule. And then 3 times 7. Subtract 1 from the power. And for B, the derivative, so dy dx is, you could also say y prime, 3 times 3, subtract 1 from the power, 4 times 2, and then this is linear, so the slope of 5x is 5. And I don't have to write this one. if we have a negative or fraction power, we can use the power rule. To use the power rule, we need a power function for a polynomial where it's x to the power. Well, 1 over x to the third is not plain x to a power, and it's okay if there's a coefficient. So we have to change the way the original function looks before we can use the derivative rule. To move this term out of the denominator, we make the power negative. Now we can say the derivative is negative 3 comes to the front, subtract 1. Then I have to fix the way that looks. A negative power moves back to the denominator. And so our derivative is negative 3 divided by x to the 4th. For b, we have x to the 1/2 power. So our derivative is 1/2 comes to the front. And then I have to do 1/2 minus 1. Need some scratch paper space. All right, 1/2 minus 1. Well, I'm going to make 1 2 over 2. That's negative 1/2. That has to move back to the denominator. So this 1/2 power will move to the denominator with the 2. And then I can make this look a little bit nicer. A 1/2 power is a square root. So really what we started with here is the square root of x. So the derivative of the square root of x is 1 over 2 root x. So then for c, before we can do any calculus work, we have to write the cube root as a power and not in the denominator. So this is all the original function. No calculus occurred. So now for the derivative, the negative 1/3 becomes the coefficient. I have to subtract 1. That's 3 over 3. That's negative 4/3. The negative power moves to the denominator. I think I want to write that again as a radical. So this denominator is going to be the cube root of, and then x to the 4th. I don't know. They're interchangeable. We can say or. Both of them are fine. When you have a polynomial, we just use all the rules. We're going to combine them all. So pause the video here and try 3. Okay, for a, we've got the derivative is 10x plus 3. So 5 times 2, subtract 1. This is linear. It's just the slope of 3. Or you could think of it, the slope of 3x is 3, and the derivative of this constant is 0. All right, for b, 7 times 3, subtract 1. Bring the power down, subtract 1. The derivative of 13, well, I guess I should say minus 0, is 0. And I'm only writing that 0 because I knew I had to fix some stuff up here in the equation before I get my final answer. So the 5 divides by 5. So we get 21x to the 6th minus x to the 4th plus 4x. All right, for c, 3x squared. 2 times 0.2 is 0.4. Get rid of that. So our answer is 3x squared minus 0.4x plus 1.3. All right, and last but not least, number 4. for A, we've got a square root, we've got a denominator and a radical in the denominator. There's one derivative rule that I've memorized that saves me a lot of work. I'm just going to flip back a second. This square root derivative between making the radical into the 1/2 and then getting a negative power and then moving it back and then rewriting it as a radical, I like to memorize that the derivative of the square root of x will always be 1/2 root x. That's a good flashcard. That's a good note card rule. So I think it would be in your best interest, and it will create less work to memorize, that if y equals the square root of x, then the derivative will be 1/2 root x. Because now I can just use that here. I don't have to change that to a power and do all that work. So I have to rewrite this equation before we can do any derivative work. I'm going to leave the root x because I'm just going to use this rule. I'm going to move the x squared out of the denominator. And I'm going to move this x out of the denominator. And it's a fraction because the square root is a power of 1/2. Okay, so now we're at a spot. We can do the derivative. The 5 coefficient stays. And then times the derivative of the square root is going to be times 1/2 root x. Minus, so then -2 times 10, -20, subtract 1. And then -1/2 times 1/2, I think I'll just write it like this. Subtract 1, -3/2. All right, so to get our fixed up answer, that's attached. Okay. Now that I have more space, to get our fixed up answer, 5 times 1 is my numerator, 1 times 2 root x is the denominator, minus a negative is plus. This has to move back to the denominator. Multiplying my fractions here, I get -1/4. Oop, but this is going to move to the denominator as a 3/2 power. And I'm going to put the 1 in the middle. That looked weird. All right, so our final derivative is 5/2 root x, plus 20/x cubed, minus 1/4 x to the 3/2. All right, and last but not least, for B, f prime of x is 3 times 0.1, subtract 1. √2 times 2, I'm going to leave that as an irrational number. I don't want that whole decimal. Just leave it like that. And then same thing with the exponent. It's just √2 minus 1. You could type those into a calculator, but I don't know. This is exact and not estimated since those decimals go on forever. All right, your practice is page 25, the odd number problems, 1 to 25 odd. And then we will start our test review in the next class.